So welcome back, guys. Today we are going to continue from where we stopped in our last class. If you have not watched our previous episode, I would advise that you try by all means to see that you revise them or you watch those videos, because all my videos are interconnected. Okay, if you want to gain the best out of this series, because I'm really trying to prepare you to see that you pass your exams perfectly and that you sit for these exams and you pass once and for all. So welcome back to this channel. If you are new, please, a subscription can help this channel grow more and to reach more people. So you can subscribe, you can like, you can share this video for greater reach. And wherever you're joining us from, you can drop your location, you can drop your country, so that we can welcome you properly to this live. So this is physics. For this year, we are preparing ourselves for the best results. In our last video, we stopped at question 39. Today, we'll finish this particular question. Then from tomorrow, we'll go into another series where I'll be giving you the top topics, the major topics that will be coming out in your exams based on past experience. Yes, the topics that you will be expecting from WAEC and that are always relevant when it comes to physics exams. So stay tuned to this channel for latest and the brightest information. So question 40, let's begin with this question. When the pressure in oil is increased, the viscosity of the oil would be, that what will happen to the viscosity of the oil if the pressure increases? So the key ingredient to this question: number one, pressure; number two, increased; number three, viscosity. Exactly. So if you're able to itemize your triune concepts, if you check this channel, one of the name of the channel is triune. That is three. If you check your physics formulas, they are always in threes. Equations are always in three parts. And life generally operates in three forms. So these are some of the secrets you can use in memorizing formulas, because you know how they are formed or their arrangement. So here, when the pressure of an oil is increased, remember the substance here is oil, all right, is increased, the viscosity of the oil would be what? This is the same substance, oil. So is it this increased, decreased, constant, increased, then decreased? So which of these options is correct? If you look at this topic, this should be SS1 work. So the best answer to this will be increased, which is option A. So I'm going to shade option A for you, because the effect of pressure on viscosity of oil for liquids increases. Why? Because increasing pressure generally increases viscosity slightly, because molecules, okay, the molecules will be forced to get closer, more tighter together. So the molecules are tightly bound, and because of that, it will increase. Is that clear? So that is that for this particular question. Then question number 41. What is the number of neutrons in this? What element is this? What is the number of neutrons in this particular element? what is the number of neutrons in carbon. So you can see we have 14, we have C, and then we have this 6, isn't it? So we are asked for the number of neutrons. If this should be SS3 work, because we know the number of neutrons, generally we are given N equals A minus what? Z. N equals A minus Z. So we need to find A and we need to find what? Z. So from this question, based on this, what is our A? Our A is the mass number, and this is our mass number, which is what? 14. Then our atomic number, what do we have? Our atomic number is 6. So our Z equals 6. So N equals A minus Z. What am I having? I will have N to be 14 negative 6. And 14 negative 6 will give me 8. So our answer is what? 8. Option B is the correct answer. I hope you are following. So please know some of the formulas under this particular topic. Very important. This topic is always relevant to WAEC. Right? Don't ignore this particular topic. Next question. The ice and steam points of a resistance thermometer are 12 ohms and 20 ohms respectively. Calculate the resistance of the thermometer at 10 degrees Celsius. Now, this is SS2 work, purely SS2 work. Now, you should know this is under heat. Yes, under heat. That is heat 2 in SS2. Now, if you observe, basically under this topic, I'm going to guide you on what to do. Immediately you see question under this topic, you should draw a line. Draw another line this way, then draw a line across it, draw another line at the base, then draw the third line. This third line is going to be at the middle. Is that clear? So if you are able to achieve this, what you are going to do is that this is your highest point, which is your steam point. Okay, always write 100 for degrees Celsius, for Celsius or centigrade thermometer. Then here you write 0. This is your unknown temperature, T of C or theta of C. Is that clear? Now, if you observe this question, they say the ice and steam point. So this is your ice point. This is your ice point. And this is your steam. And this is your steam point. Your steam point. Is that clear? So this is your unknown. This is your unknown. This is what you are looking for. So if the ice and steam points of a resistance thermometer, we now know that this thermometer we are trying to convert from is a resistance thermometer in ohms. Okay, since the SI unit of resistance is ohms, then are 12 ohms and 20 ohms. So the ice point is 12. So you write your 12 here. Okay, then the steam point is 20. You write your 20 here. Is that clear? Then calculate the resistance of the thermometer. Calculate. It means you are looking for T of ohms. It's unknown. If the temperature given here, okay, is 10 degrees Celsius or centigrade, so our T of C is given to be 10 degrees Celsius. Is that clear? And we know that this is now the complete data when it comes to Celsius thermometer. Is that clear? This is another thermometer. So what we are trying to do, we are trying to convert from Celsius to resistance thermometer. Is that clear? So generally, how is your formula meant to look like under this topic? Your formula is meant to look like this. Okay, the unknown temperature, exactly, minus lower fixed point, all divided by upper fixed point minus lower fixed point. If you understand this formula, any question that come under this, you solve it. Unknown minus lower fixed point divided by upper fixed point minus lower fixed point. So looking at this formula, we are going to have r of theta minus r naught divided by r what now? 100 minus r naught, which will equal theta over 100. And from this particular question, our theta is 10. Okay, so begin to substitute. Our r naught is unknown, our r theta is unknown, minus 0. What is our lower fixed point? Minus our lower fixed point from the question is 12. Okay, so we're going to have minus 12 all divided by 20 minus 12, which will equal 10 over 100. Are you with me? So with this, we know that 10 divided by 100 will give me 0.1. So I have r theta minus 12 over 8 equals 0.1. When you cross multiply, 8 multiplied by 0.1 will give us 0.8. So r theta minus 12 equals 0.8. So that r theta will now equal 0.8 plus 12. So that we have 12.8 ohms. That gives us our answer to this question. 12.8 ohms. B is the correct answer. Is that clear? So that is that for this particular question. So go and read on thermometer. This topic is a good one for JAMB. For WAEC, they love this particular topic so much. All right. So let's proceed. Question 43. 43. Question 43. A radium nuclide decays by emitting alpha particles as shown. This is the decay. Determine the daughter nuclide. Now, if you observe from this question, you will see that it exhibits the alpha decay. And the alpha decay given to us is what? Is 226. Then we have 88 Ra minus X plus what? 4 over 2 of helium. Exactly. So from here, we know that in alpha decay, the mass number decreases by 4. Isn't it? The mass number decreases by 4. You can see it here. Let me circle it. This decreases by 4. And what happens again? The atomic number decreases by 2. Exactly. So what are we going to have as our mass number now? Our mass number, let me use this please. Our mass number will now equal what? 226 minus 4. 226 minus 4, which will give us what? 222. Then our atomic number will now equal 88 minus 2. 88 minus 2, which will give us what? 86. Are you following? So this particular question is always simple and easier to understand. So from here, what do you think your answer will now be? Your x particle will now become what? 222 and then 86. 222, 86, which is what? Option A. Option A is your correct answer to this particular question. If you have any questions, you can drop them in the comments. When I come, I will do justice to these questions. Is that clear? Now, for a bullet of mass 0.025 kg moves at 250 meters per second. Calculate the Broglie wavelength. We are given our Planck constant to be 6.67 times 10 raised power negative 34, okay, joule second, and then we have our charge to be 1.6 times 10 raised power minus 19 coulomb. So from here, we are asked to calculate for wavelength. Okay, the main thing you should know here is that we are looking for the wavelength, because the Broglie's wavelength is given by mass, velocity, and the Planck constant. And what's the formula? If we make this is our formula, we have h over mv. This is our formula. This is what we're using. Is that clear? So if this is what we are using for this particular question, then what is our mass from here? Our mass is 0.025. So we are going to substitute into this. We are down space. So how am I going to do it? Let me write it here. So I'm going to have 0. So I'm going to have our wavelength. Our wavelength will be equal to what? Our wavelength will be equal to 6.67 times 10 raised by minus 34. 6.67 times 10 raised by minus 34, all divided by, what do we have? Mass 0.025 minus, what is our velocity as given? 250 minus, multiplied by 250, not minus 250. Is that clear? So from here, if you do this, let me punch my calculator. If we do this, what are we having? We are going to have 1.07 times 10 raised by minus 34 meters. 1.07 times 10 raised by 34 meters. This is our answer to this particular question. So once you hear the Broglie wavelength or whatever, this is what you are using. Exactly. Use this particular formula to solve your problem. If you are with us, signify in this live, and if you have questions, you ask so that we'll move along. And if you have questions, you can type them so that in our next live, I will do justice to these questions right here. So let's go to the next question. An electron moving with a speed of 5.0 times 10 raised by 5 meters per second enters a uniform magnetic field at 90 degrees. Calculate the magnitude of the magnetic force on the electron if the magnetic field intensity is 0.25 Tesla. All right, we are going to take charge to be 1.6 times 10 raised by minus 19 coulomb. So we can see that our answers are in what? Newton. So meaning we are looking for force. We are calculating for the force. So what are we going to do? We know that under this particular topic in SS3, that force, okay, force equals what? QVB sine theta. I believe you have seen this formula somewhere before. Our angle is 90 degrees, okay, and sine 90 will give us what? sine 90 will be equal to 1. So everything here gives us 1. So if we continue, we can now say that f will now equal what? What is our q? From the equation is 1.6 times 10 raised to the power minus 19. Okay, then v multiplied by our v is 5.0 times 10 raised to the power minus 5. Okay, and then our b is 0.25. So if you multiply all this together, you are going to have 2.0 times 10 raised to the power minus 14 Newton. 2.0 times 10 raised to the power minus 14 Newton. So B is the correct answer to this particular question. Now, please go and read on this topic in SS3. It's very important. Please take notes of this particular topic. Please, I will repeat again, go and read this topic. Okay, go and read it. Go and read it. Under magnetic field, alternating current, and the rest in SS3. Very important. They are all connected. So please take note of this. Then question 46. A beam of light which appears to come from a point in space is said to be what? Is it convergent, divergent, parallel, or circular? A beam of light. Remember, we have ray of light, then we have beam. Beam is the collection of rays. Okay? Beam, the collection of rays, gives you beam of light. So beam of light appearing from a point will do what? Will spread out from a point. So it will spread out from a point. Let's assume you are having a torchlight. What happens to it? They will spread out from the point. So we'll call this as what? Divergent. So the answer to this is divergent. B is the correct answer to this. So 47 now. A sound wave made up of large number of unrelated frequencies superimposed on each other is called what? A sound wave made of large number of unrelated frequencies superimposed on each other is called what? Harmonics, note, noise, and pitch. What can you say about this particular question? If you are with me, can you drop the answer to this question? I'm waiting for you. Yes, if you are part of this live. Based on your definition that you know about harmonics, you know your definition about notes, you know your definition about pitch. What about noise? A sound wave made up of large number of unrelated frequencies superimposed on each other. What would you call them? It is simple. You call them noise. So your answer is noise. If you are correct, indicate in the comment section so that I will identify you. If you are correct, indicate in the comments so that I will recognize you. Question 48 is under frictional force, SS1. A boy pushes a box of mass 80 kg along a horizontal floor with a force of 200 Newton. If the box is pushed with a uniform velocity, what is the coefficient of friction between the box and the floor? What is the coefficient of friction between the box and the floor? Are you here? So, if you observe, the mass is 80 kg, okay, and the force applied is 200 Newton. Is that clear? So we are asked to find the coefficient of friction. I will know that F equals what? Mu R, right? So if you are looking for mu, you say mu equals what? F of r over r, isn't it? And from the equation, we are given our force, frictional force, to be what? 200 divided by our r. What is our r? If you check, mass is given to us, and we are given acceleration due to gravity. So for us to obtain r, we say r equals mg. So that mg will give us 10 multiplied by what? We have 10 times 80. So that we have 800. Exactly. So if that's the case, I have 800. 2 zeros will cancel out 2 0. Our mu will be 2 upon 8. And 2 upon 8 will give us what? 0.25. So this is our answer. Option A is the correct answer to this question. I hope you are with me. So please, I believe you are learning one or two things. Apply what you are learning and remember them. These are common formulas you must know so that you pass your exams perfectly. Then question 49, isn't it? Extremely thin wires can be drawn from platinum simply because platinum is what? Extremely thin wires can be drawn from platinum simply because platinum is what? Is it crystalline? Is it ductile? Is it hard? Or is it malleable? So I need you to drop the answer to this question in the comment section. Yes. If you're able to draw thin wires, okay, from platinum, now what would you call that ability? What would you call that process? Would you call it ductile or crystalline or hard or malleable? So the best answer to this is ductile. Who is correct? If you are correct, drop it in the comment section. Let me see. Yes, ductile is the correct answer to this question. So you can see the last question here. So cheap, right? You can see how cheap it is. The SI unit of inductance is what? The SI unit of inductance is what? Now, you can see that if you miss this topic in SS3, you have issues. Okay? You are meant to have treated this in SS3. Now, you have the RLC circuit. Who discovered R is Ohms. Who discovers C is Faraday. Then this is Henry. So which is why this one will use Farad, this one will use Henry. Exactly. Then Coulomb is for charge. Then Hertz is for frequency. So if you know some of these things, you'll be able to, from inductor, we have inductance. Inductor is a component. Inductance is the function, is the ability, okay, to perform its function. That is it. Anything that you see ends with tans, resistance, capacitance, you are now talking about the ability. You are referring to the ability of the substance to perform their function. Is that clear? So from here, our answer is C, which is Henry. Is that clear? So that is that for today's session. If you have questions, drop them in the comment section. I'll do justice to that. In my next class, I'm going to drop the most top topics. I'll drop the top topics that you would expect from this year's exams, WAEC exams. I'll drop them, even NECO, I'll drop them. Then I'll also give you some formulas that you must know, those equations that you must know, the area of concentration, and then I'll also the tips and tricks on how you can pass your physics exams and answer those questions without wasting time. Because sometimes many people find it difficult to meet up with time. That is one of the major issues. So please, I'm going to guide you on how to maintain time while solving your question. Is that one clear? So please join us in our next episodes. I'm going to be helping you out, and you must pass these exams. And as time progresses, we'll now go into section B. Then we'll go into the practical aspects. Is that clear? So if you have any questions, you can drop them in the comments. Thank you for joining us today. I will see you in the next one.